Thank you, Niklas. I'm Henrik Nydell, Product Manager at Accedian Networks, and I'm going to talk about automation of network and service assurance today. So what is the Accedian Skylight portfolio? So Skylight is a set of functions, a framework for bringing visibility of performance into your network, looking at both the infrastructure, service layer, and it's built out of 3 different distinct tiers. So at the bottom, we have the sensors, the Skylight sensors. So you see a couple of them shown there. I'm going to focus mostly today on the agent type, which is the containerized test functions, but we'll also have other types of sensors. In the layer above, we have the orchestration tier, and this is where you control and set up the tests and define what will be done with the test results and how long you should test and those types of things. And then on the top layer, we have the Skylight Performance Analytics layer, and this is where all the magic happens with the metrics results. We can do correlation of data, we can do integration of third-party metric streams like telemetry and so on, and bring it all together as a comprised view of how well your network is and services are performing. So let's zoom in on the sensor layer to begin with. So in the Skylight sensor layer, as I mentioned, we have a couple of different types of sensors. So we typically refer to them as CNFs, VNFs, and PNFs. So the CNF is our containerized test agent, which is deployed as a software-only container. The VNF is a virtual machine that you deploy as a standard VM in your VM infrastructure. And the PNF is a pluggable piece of hardware that we have integrated our own FPGA into, which can be used in situations where you do not have possibility to install software. You can then plug our pluggable hardware module in there. The example shown here is the SFP Compute, which is an SFP module, of course, so an optical device that runs at 1 gig or 10 gig, but can be plugged in any SFP port in a networking device and then bring Skylight visibility to that location. So regardless of which form of instrumentation you pick or you choose for your application, they can all perform various types of tests. And they can test either towards another Skylight sensor or towards a standard reflector or to a third-party service. And what does this mean? So I'll dig into a little bit what these different categories mean. So when we are testing between 2 test agents or 2 Skylight sensors, we typically call this as a bookended test. So in this case, it is usually a transfer-based test. We can transfer X amount of traffic from location A to location B and monitor how long time it takes or what bandwidth you got. Or it could be a more continuous type delay, jitter, packet loss type monitoring, where you want to have an SLA of a path or a service. The second category of tests we refer to as reflected tests, and these are usually defined based upon some kind of standard. The most common standard would be the RFC 5357 TWAMP, which is a layer 3 test protocol used to monitor delay, jitter, and packet loss. So with these types of tests, you have a Skylight agent or a Skylight sensor only at one end of the test. At the far end, you instead rely on enabling that reflection service in the router or in the switch or in the server that sits at that location. The third category of tests we call the service type tests. And in these types of tests, you have some kind of service that sits at the far end. Typically, it could be an HTTP server or an FTP server, something that responds to messages and can reply to us with some data. So with these types of tests, we can, for example, provide a download speed indication from a certain web service and report that all the way up through the Skylight portfolio. So how do you then deploy these test agents? So the CNFs, as they are containers, they rely on a container environment, but they can be deployed in virtually any type of virtualized environment. So we have customers using them on servers, on Linux OSs, whether it's physical or virtual servers. You can also deploy them in an orchestrated Kubernetes environment, such as AKS or Google, but also Red Hat's OpenShift is an environment that has been reasonably common to deploy containers in. And also, quite interestingly, you can deploy these container agents on network devices or network components. So Cisco XR and XD has support for third-party applications, and also other vendors that you may have in your network may support installation of third-party containers. So I'm mentioning a few here. Cradlepoint is one that has an ARM processor capable of taking containers. We're also testing Versa and VeloCloud right now during the spring. So when you deploy one of these CNF agents on your device, they will of course consume some kind of resource, but the footprint is quite small. It's just a couple of % of a CPU core if you want to do continuous 24/7 type SLA monitoring. And if you want to do throughput testing, we can get all the way up to 10 gigabits per second with just a single CPU core. And memory and disk consumption is quite small as well, around 200 MBs of disk space and RAM. So one important aspect, and this also comes back to the deployment of the test agents, is that these are single purpose. So we follow the container and microservice manifests and architecture. So each agent has a single purpose. So if you want to do testing of throughput, you would then deploy the throughput agent. And you can then, once the test is finished, you can destroy the container and redeploy with a different agent that performs a different type of test. So we do this to minimize both the amount of processing that we use, but also the footprints in the network. So you only have the tests deployed that you are actually going to use. So I'm mentioning the agents that we have available right now on this slide here. At the bottom, you see SDK, and this is something we are working on at the moment. So we're working on this together with a couple of our key customers to develop a framework for them to deploy their own tests using the Skylight framework for automation of service testing. So the idea there is that if you have test applications yourself, you can then roll them into a Skylight agent through this SDK and deploy and control them through the Skylight framework, just as if it was an Accedian agent provided by us. So this is something that we're going to launch a little bit later on this year, the SDK. So around automation, the key aspect of this presentation. So I've talked about that these containers can be orchestrated and controlled, and this is, of course, a key aspect of a monitoring solution these days. You need to be able to to automate every phase of the whole life cycle of service assurance and service testing. So starting with when you actually deploy the agent, so this can be automated, of course, since it is a container, we can rely on the existing container orchestration mechanisms out there to deploy agents at the locations where they are needed. Agents intrinsically support an outbound phone home architecture, so agents are completely useless, you could say, when they do not have a controller sitting on top of them. So the agent, when it wakes up, knows nothing, but it performs a phone home towards the orchestration service where it can register itself and then get information on what type of test to perform, which destination to test to, and so on. So this deployment can be done quite easily straight off the internet by using Docker pull. So all our agents are publicly available on GCR, on the Google repository. So you can immediately install and get it running by just doing a Docker pull. Or you could, of course, orchestrate it through Kubernetes or similar types of container orchestration mechanisms. We're soon also going to allow installation through Cisco's XR App Manager. So this is a feature within iOS XR that allows you to control third-party applications directly from the CLI. And this also gives you the possibility to use netconf yang to actually execute the package install and package activation of an agent like this. But if you're using something simple like Docker Compose, there is an example here on this slide on what you would need to provide. So basically, the agent only needs a couple of things to get started. It needs an ID, a name, the point of registration where it should dial home, and a secret or an authentication token to register. That's all. And once that is provided, it can start up and be ready for testing. So when the agent has registered with the orchestration service, circled in blue there, it is now ready to take actions. So you could either have already pre-provisioned what it should do when it wakes up, or you can trigger it through our open APIs. So you can list which agents you have registered, which have appeared, and you can then tie them together to define where to test from and where to test to. So here's an example of the JSON to trigger a test, to set up a throughput test, defining a name of the test, which agent that should perform it, where to test to, and duration, and so on. So you can define multiple tests for every agent. For throughput testing, you can define tens of thousands of tests if you want. But for throughput tests, you can only have one test running at any point in time, right? But you can have a large number of tests defined and then select which one to run. And this is, of course, also API driven. So you would signal through the open APIs which agent and which test to start. And it will then begin running and reporting the data. So once the agent is starting to report the data, this happens northbound to the blue circle at the top in the Scala Performance Analytics layer. So we can then take this measurement data and correlate it with other types of streaming metrics or streaming telemetry, and or feed it to a third-party consumer of the metrics and any associated data. So on the analytics layer, you can, of course, also graph and visualize the metrics. But for the purpose of integration with Cisco, we are using mainly our data bus to feed the metrics into Cisco so that you will have a closed loop of the metrics. One advantage with the Skylight Analytics layer is that we perform data cleaning and data aggregation. So if you have multiple sources of data that are, for example, reporting at different intervals, we can then normalize that data and feed it to you in the chunks. If you want 5-minute buckets or 1-minute buckets or 10-second data, we can do that for you. There's also built-in aggregation, alerting in the analytics layer, so you can define thresholds for any of the metrics and get those alerts delivered on the message bus. So how does this look like when brought into Cisco CNC and NSO? So of course, Cisco CNC sits as sort of the brain in this closed loop circle. CNC can signal and control through our orchestration services which tests to add and perform, and also where this data is looped back through our Skylight Analytics layer back into CNC. At the bottom right, you see also the third-party data source, and we have the possibility to bring in Cisco telemetry, for example, into our data pipeline, so that you can collate this data together with the Accedian sensor data and get a very complete picture of how well your network performs. So let's take a look at how this connects into the Cisco NSO. So we have added Yang models and the REST-conf interface to our orchestration layer to allow NSO to signal and control the creation of tests and starting, stopping, and so on, controlling the whole phase of testing with the sensor agents and sensor control. So the test provisioning can be done both on our VNF and PNFs, as I mentioned, and the CNF solution. So currently we support 2 different test types with Cisco NSO, RFC 5357 TWAMP and RFC 6349 TCP throughput testing. So we are going to add the other test types as well during the months to come, but these are the 2 that are available at the moment. On top of that, NSO can provision metadata into the Skylight solution. And metadata is important to be able to do correlation so that you can tag a certain measurement to a certain location or a certain device. And this gives us the ability to cross-reference tests and provide much richer metrics and results out of this. You can also define alerts and thresholds from NSO through the Young models so that you can set your SLA limits and get the alerts back into Cisco portfolio. So an example of what this could look like, which we've done with a customer at the moment, where Cisco CNC is sort of, again, the brain and the context keeper of the solution. So this is where information is kept about the service details, what links are out there, and names and so on. So CNC knows which services it is deploying and setting up in the network. So in the example of a layer 3 VPN service, CNC has the context of that and can then provide through the Young models into Skylight that context so that we can set up a performance monitoring, for example, or a throughput test on the newly created layer 3 VPN service. So in this particular deployment, we're using a Kafka bus to communicate alerts back from the Skylight solution. And we're also using a third-party system, Vitria AIOps, to create a transaction system for the whole deployment. So please check back on May 12th, where we will have also a demonstration of an integration with Cisco NSO and Skylight. That's all for today. Thank you.